In this lesson, we're going to talk about measures of dispersion. One thing that we discovered in lesson 10.2 is that sometimes the mean and the median can compete for which one is a better measure of center. If the data is spread out too far, it makes it so that the mean is not always very useful. One way to look at this is to look at the range. Another one is the quartiles can be used to construct a box plot, a visual that's kind of helpful. One more is called the standard deviation. It's a little bit hard to use, but not too bad. The standard deviation is a very common statistical measure for how spread out the data is. The range is simply found by taking the highest number minus the smallest number in the data. It tells you how wide the data goes. And a box plot, which we'll do a picture of, is a drawing that basically shows your three quartiles as well as the minimum and maximum value. It gives you a feel for how spread out the data is. Let's do an example with the two examples we did in 10.2. We have 11 different movie times, and for the range, all I have to do is take the 155, the highest number, minus the 88, the smallest number, and that is the range. You get 67 minutes. So among all the data that I have here, there's a 67-minute difference between the shortest movie and the longest movie. That's a really large number. That's why we had to discuss the things that we did about how far apart the mean and the median were. Next example, it looks like the highest score in this class was a 98, and the lowest score in this class was a 67. So the range in this case is 31. I think I will actually put points as a unit this time, since we're thinking about scores on a test. That's all for range. Now let's look at the box plot. We looked at these two data sets and we found the quartiles that we have listed here. To draw the box plot, what we'll do is look at the smallest and largest numbers. Looks like my smallest number is a 2 and my largest number is a 15. So I'm going to make a little scale that goes from say 0 to 20, and I'm going to go by 2s. On this scale, we can put what we call the box plot. The box plot takes each of these quartiles and draws a vertical line to generate the box. So 5 is a vertical line, 8 is a vertical line, and 10 is a vertical line, and I'm just going to draw a box using those. This shows the first, second, and third quartiles. Then you draw what is sometimes called whiskers that goes out to the smallest value of 2 and the largest value of 15. This box plot shows us where half of the values are between this 5 and 10, and then how far apart the rest of the data is. Let's do another one. In this one, I see 10 as my smallest number, and 20 is probably a decent upper number to put in my scale. Now let's draw the box plot. The first quartile was at 13, the second one is at 15.5, and the third one is at 17. We'll simply fill in the box, and this is the middle half of the data. Now let's draw whiskers. They go out to the smallest value of 10 and the largest value of 19.